Okay. 9h is wrapping logarithm functions. Who remember what is this graph look like? Y equal to 2, y equal to 2 to the power x. Who remember what does it look like? Let's do the participation. Okay, what does it look like? 2 to the power x. Very good. 1 point for Mark. It's going to be look like this. Right? Remember this? Exponential function? Yeah. Exponential function. Do you remember this? We learned this before. Right? So today we're going to something like this. You're going to learn how to do something like this. First, I'm going to give you 3 points. If you can answer this. What do you think is the relationship between this function and this function?
They're the same thing, just without the rod.
They're not the same, but they're related. But related in what way? There's a relationship between these two. So who can answer? I'm going to give you 3 points. Huh? They are base. What? So if they're not the same, then what are they? What do you mean opposite?
They're like mirror.
What do you mean mirror? That's a word.
Reciprocal?
Huh? Reciprocal? Okay. I'm gonna do this. You're gonna tell me what I'm doing. Okay. Can you see the color? Is that okay?
The inverse?
Inverse. Yes. Did you see? I'm switching x and y. Okay, 3 point for Elizabeth. And then x equal to 2 to the y, right? And then I'm gonna solve for y. Do you remember this process? You switch x and y, and then you solve for y.
Oh yeah.
That's how I started. Yeah.
Very good.
Here, if I want to get y, I'm gonna do log 2. Log 2. I take log 2 of both sides. Why? Because log 2 of 2 is 1. And then I have y equal to log 2 of x, and that is exactly this. You see? That is why these two are inverse. So now this another 3-point questions. So now you know these two are inverse, right? These two are inverse. Can you tell me what this graph look like? It inverse of this.
Oh, so just
Yeah, this is see on your way. See a lot like this. Okay. Okay, how about you? How about you? Like this? Okay, I have. Okay, you doing it? Okay, so 1 point for Bristan, 1 point Andrea. It's gonna be okay. This is the one for here, right? I just write. Do you remember this unit 8? We learned how to wrap. No, it's not. It's not the inverse yet. They're going to inverse over this line. Remember?
Yeah.
They're gonna mirror over that line. So what does it look like then? That's what you did?
Yeah.
So we're gonna look like what? We're gonna look like this. Is that what you did? Yeah, okay, just give Mark 1 point. And Andrea 1 point, Krista 1 point. Does it make sense? This is we only learned on unit 8. You remember you're gonna find a good one over here, and then you switch the x and y, you draw a new one. The new one gonna be reflect over this diagonal line, remember? Okay, that's right. Y equal to x. This line y equal to x. Yeah?
Yeah.
So This graph, the original log, they're gonna be look like this. Okay, so this is y equal to log 2 x. Okay, we're gonna learn how to graph that. Okay, the first one, y equal to log. Let's do the basic. So log 3x. Okay, log base 3 of x. So the question is gonna be graph the log function. Whenever we want to graph, what do we need to do?
Find the X equals.
The table. Very good. I'm going this way. I already wrote down the step by step for you. You can write down first. Find the domain. You're gonna let inside a log larger than 0. Next step is draw the vertical. Okay. Another question I forgot to ask. When you graph this, what is another information you need to know?
The vertical is.
No, for this. For the exponent function. HA? What is HA? Yeah, horizontal, right? Horizontal. So this is HA. Then for this one, this is inverse. What do you think we need to know? Vertical asymptote. Yes. That's one. The second step, you need to draw the vertical asymptote. This is the vertical asymptote right here. Okay. Find the intercept. It's optional. I will tell you why. And then the last one is pick a good point. I will tell you what is a good point we're gonna find. Okay. Let's do the first one first. Find the domain. Did you write this? Let's take a time to write that first.
Yeah.
So the step by step is okay. First step, find the domain. How? You're gonna let inside the log larger than 0. Second step, you're gonna draw the vertical asymptote. That is the number for the domain. We're gonna work out so you know what does it mean. The third step is find the intercept. You let the whole thing equal to 0, but it's optional. I will tell you why. Sometimes it's complicated. The last step is you're gonna pick a good point. I will tell you how to find a good point. So take a time to write down first. Okay, first thing first, you want to find a domain. You want to find a domain. You let inside a log larger than 0. What inside a log right here? Huh? No, inside the log, 3 is the base. So what inside the log? What inside the log? 3 is the base. Where's E? Where's E come from? Why? Inside the log. Log of what? 10? Okay, log base 3 of x. X is what inside the log. Yeah?
I said it.
You said x?
I said it after.
So you want to let x larger than 0, okay? Because x is what inside the log, so that is the domain. Easy, right? Whatever inside the log, let them larger than 0, and that is the domain. Okay, next you're gonna draw the vertical asymptote. The vertical asymptote you're gonna get from the domain. So this is 0, right? So this is the vertical asymptote. This is the VA. Remember, horizontal is the x-axis. You start on x-axis. The vertical is from y-axis. So 0, that's mean y equal to 0. This is mean y equal to 0. Where is y equal to 0? What line is y equal to 0? Y-axis, yes. 1 point of circle, yes. This is the y-axis. Okay, this is the VA. So those are 2 steps already. Okay, the next step you want to choose the point, so that's the whole thing equal to 0. Question: if I want this one to be 0, what is x? 1. Very good. 1 point for Mark. Why is it 1? Why x is 1? Why x is 1?
Whatever is the power of 0.
Everything to the power 0 is 1. You want to ask yourself 3 to power 0 is 1. Everything to power 0 is 1. So x is 1. So that is the point I'm going to choose. X is equal to 1. Okay. When x is equal to 1, log 3 of 1 equal to 0. Yeah, that's a good point. You need 3 points. Okay. What is the next good point, you think?
Zero.
You already have it.
0?
Oh,
You already have it.
Okay, look at this. Look at this. If you choose x to be 0, what is log by 3 of 0? 1? So you say 3 to the power 1 is 0?
That's three. That's zero. That's zero. No, that's three.
Look at this question. Now I'm asking you, if you say this is 0, 3 to what power equal to 0? 3, think about it, think, listen carefully. 3 to what power equal to 0? Yeah, 0 is 1.
One. Negative three.
Negative.
3 to negative 3 is 1 over 27. Negative 1 is 1/3. Is it possible
No.
to have 0? No. There's no power that you can get the power, you get 0. So that's why when I said 0, it doesn't make sense. Remember, maybe you can write a lot. We can write a note like this. Inside the log must be larger than 0. So write this down. Inside the log must be the number inside the log must be larger than 0. It can never be 0. It can never be negative. Because any number, you take the power, they can never be negative. Yeah? So what is the next good number? 9 is good. It's not the next best one, but 9 is good. Okay, let's choose 9. Why 9 is good? Let's look at this. If you plug in 9 here, then you plug in a 9 over here. So log by 3 of 9. What is log by 3 of 9? 2. Why is it 2? Because 3 to the power 2 is 9. Okay? 1 point for Elizabeth and 1 point for Orlando. So 9 is a good one. I need one more point. 3, not 6. Okay, think about this. Log 3 of 6. What is log 3 of 6? Is 3 to what power equal to 6? No, right? So 3 is a good one. Don't confuse with the multiplication and the power. Log is about power. Okay. So log 3 of 3. What is log 3 of 3? 1. Very good. Easy thing. So easy point, right? Good. So give one more to Elizabeth, Andrea as well. You can participate, and then Orlando. I already update your participation point if you check it. Okay, now 3 points. You need to plug it in. 1 0 1 0 right here. 3 1 2 3 3 1 right here. And then 9 2. So again, you can just estimate. You don't need to get exactly the measurement. So 9, and maybe let's say this is 9, and then 2 over here. Let's move this one a little bit. Okay, and then connect this. The shape is going to be look like the original one. Just because there's no minus. There's no minus, that means there's no reflection. There's no flip. So it's going to look like this shape. So it's going to be like this. Yeah? And that's we done. And that's how we wrap this. Okay? Only basically just remember 3 steps. Phi domain, draw the VA, choose the point. That's it. Okay? Any questions so far for this one? Okay. Okay. What is the domain? What is the domain? What do you mean 0? It's good, but you need to make more sense. You mean what do you mean 0? X larger than 0. Okay. So give Maria and Eric 1 point. So X domain. Because what is inside the log? Is 2 inside the log? No, 2 is outside, right? there's no parenthesis. So it's a log only of x. So domain is x larger than 0. Okay. What is the VA? VA is this number. Y equal to 0. Okay. That is y axis. Yes. Very good. Come on, Sophia. Now I'm gonna choose good point. What is a good point? Sophia. What is the good point over here? What point when you plug it in here you get 0? What point when you plug it in here you get 0? Again. 1. 1. Right? When you plug it in 1, I have log 5 of 1 plus 2. Log 5, 1 is 0 plus 2 is 2. Okay, what is the next best number? 5. Very good. 1 point for Sophia. 5. Why is 5? Because log 5 of 5 is 1. It's easy for you to calculate. So this is 1 plus 2, so this is 3. What is the next best one? 25 is good. Yeah, 25 is good. Yeah, okay. If I were you, I also think about 1 over 5. 1 over 5 is negative 1. But let us do 25. 25 easy. So log.
Cross the y-axis then.
Huh? Oh, so what is log 5 of 25?
5. Wait.
2, right? 5 squared 25. So this is 2. 2 plus 2 is 4. Another option, the point you can do is 1 over 5. Why? Because log 5 of 1 over 5. What is log 5 of 1 over 5?
Negative 1.
Negative 1. Negative 1. Very good. Very good.
But if the x is negative 1 and plus.
So negative 1 plus 2 is going to be 1. That's another point.
Oh, wait, no, I forgot to do this.
Yeah?
Yeah.
So I have 3 points. 1, 2. 1 here, 2 here. 5, 3. 1, 2, 3, 4, 5, 5, 3. Right here. 25, 4. Again, I can just plug anything. Subtract 25, 4 right here. It still look like this. It still look like this because there's no negative right here. That means there's no flipping. There's no reflex over y or x axis. Okay. Easy, right? Easy, easy. That lesson is easy. I think it's just a piece of cake for you. It's just how you want to choose the point. But here, let me emphasize this. Let me emphasize this. This point, you have the freedom to choose any one you like. Okay. Don't worry, don't be stressed out. Oh, I need to find a good point. No, you don't need to. You can basically choose any point. You have calculator, you can calculate it. But back then they don't have the calculator, so they always want to choose the good points. Because when you're doing this, when you choose the good point, you don't need a calculator, right? Log 5, 5 is 1, log 5, 25 is 2. You don't need a calculator. But if you don't know what to choose, just choose any one you like and then use the calculator to get the point. You know what I mean? You have freedom to choose any point you like. Okay. We have 7 examples. X plus 3. Okay, yes. Okay, what is the domain? What is the domain for this? What inside the log? X plus 3. One more for Mark. Yes, X plus 3. So I'm gonna let X plus 3 what? Larger than 0. One more for Hayden. Yes, larger than 0. And then you're gonna solve for X. How can I solve for X? You minus, subtract 3, right? Subtract 3. So X larger than negative 3. So that is the domain. Okay. What is the VA? Negative 3. Negative 3. This is negative 3. Who said that? Negative 3. Okay. So negative 3 is the VA. So it's 1, 2, 3. Negative 3 right here. All right. Now I'm going to choose a good point. What is a good point? How do I make this one equal to 0?
Wait, no.
3. So 3 plus 3 is 6.
Oh, negative 3.
Negative 3. So negative 3 plus 3 is 0. ln of 0. Remember, inside the log
Oh,
must be
sure.
larger than 0. ln of 0 is not 0. So what number? How can I make that equal to 0? You make it become 1. -2, right? -2. Because you want to make this one become 1. So ln of -2 minus 3, I mean plus 3. -2 plus 3 is 1. So ln of 1 is 0. Yeah. What is the next root point? What do you think? If you don't know, just choose any point. 2? You want to 2? Okay, let's do 2. But why 2?
Wait, negative.
Well, you can do random thing, but at least choose some small number. You can start with 0, right? Or you can start with 1. Do you agree?
Yeah.
Let's choose 0. Okay. 0, so plug it in here, have ln of 0 plus 3 is natural log of 3. Can you use a calculator to find me what is ln of 3? What is the natural log of 3? Use a calculator. Use a calculator. And maybe you can choose 1 if you want. So natural log of 1 plus 3. So that is log ln of 4. Tell me what is natural log 3 and natural log 4.
And then 3 is 1.09.
0.9, okay, and then ln 4. 1.386 to 1.39. Okay. 1.4 Anthony and Pizza. Now you can plug it in. You know what I meant right here? See, you don't need to choose a good point. You don't need to choose a good point if you don't know. Just choose any point and use a calculator. So that's a good thing. Okay. Because T table is for you. It doesn't have any law for that. You can just use the point that you like. Okay, -2, 0, -2, 0 right here, 0 and 1.09, so 0 right here. 1 point, maybe I put it right here, 1.09, 1, and then 1.39, maybe a little bit higher than this. Okay, connect them, that's it. That's it, yeah. Are we good? Does it make sense?
Yeah.
Okay. Or okay, what is the domain? We're gonna give me exactly the domain. I'm gonna give you 2 points.
Yeah.
Give me exactly the domain. The domain means you need to tell me x larger than what or less than what or what.
X is larger than 40.
So when you divide 3, so
X larger than 0. 2.27. Why? What inside the log? 3x, right? 3x inside the log. So 3x needs to be larger than 0. How can I solve for x? Divided by 3. 0 divided by 3 is still 0. That's why it's still x larger than 0. What is the VA? 0. 0 is the VA. So y equal to 0, it's just the y-axis, right? Okay, so VA is still x-axis right here. I mean y-axis right here. Okay, choose a good point. What is the good point? What is a good point over here? 1. Let's say if you plug in 1 here, it's log 4, 3 times 1. So it's going to be log 4 of 3. You know what is log 4 of 3? So I don't think it's a good point. It's good to have log 4 of 4, right? Because we know that is 1.
Yeah.
So we need the 3x to be 4. I want this one to be 4 so that I can have log 4 of 4. Yeah? Can you solve for x right here? X is? How can you solve for x right here?
divide 3.
So x is 4 over 3. That's the first good point. So because when I plug it in here, log base 4, 3 times 4 over 3. 3 cancel out. I have log 4 of 4, and that is 1. So that's a good point. Okay, what is the next good one? How can I make this one equal to 1? Because everything to 1 is equal to 0, right? How can I make this one equal to 1? 1/3?
Oh, we just need to get a finger something.
Okay, 3 and 3 cancel out. We have log 4 of 1. What is log 4 of 1? 4 of 1 is 0. Okay. What is the next good one? What is the next good one? Again, you can choose any point, but I think there's a good point to choose. Okay, the next good one that I can do is maybe log 4 of 16. Okay, I want this whole thing to be log 4 of 16. Because log 4 of 16 is what? 2. So I want this 3x equal to 16. So that's why I need 3x equal to 16. How can I solve for x? Divide by 3. So x equal to 16 over 3. So I choose that to be the next point. Log of 4, 16 over 3 times 3. Let me consistent with the color. So log 4, 3 times 16 over 3. Log 4 of 16 is 2. Do you know why we choose 4 over 3, 1 over 3, 16 over 3? Why? You know why, right? Why do we choose 4 over 3? Can someone just summarize it again? Right, because when you plug in 4 over 3 over here, 3 and 3 cancel, log 4 and 4 equal to 1. That's a good point. How do I find 4 over 3? I let 3x equal to 1 because I want this 3x equal to 1. And then I solve it. Divided by 3, x equal to 1 over 3. So we're talking about this. Okay. Now plug in the point. 4 over 3. 4 over 3 is log n 4 divided 4 over 3, 1. 1 over 3, 0. So this is 1 over 3, 0. And then 16 over 3. 15 divided by 3 is 5. So I know this one a little bit larger than 5. So maybe here, 16 over 3, 2 right here. So let me know if this is slow down, or let me know if you have any questions. Okay. So connect the point. Again, if you grab this and you have this one cross the line, it's wrong. It's gonna be point off. Okay. Any question for number 4? Have we go so far? Yeah. 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 Okay, number 5. Log base 3. 2x minus 3 minus 1. Okay, log base 3, 2x minus 3 minus 1. Okay, what is the remaining? 2x minus 3. So what is the remaining? What is inside the log? What inside the log? 2x minus 3. Very good. So I let it what? Greater than 0. Do you know how to solve this? What do I do first? Plus 3. Very good. So 2x larger than 3. What next? Divide by 2. So I have x larger than 3.5. So this is the remaining. You need to solve for x, okay? And what is the VA? What is the VA? 3.5. So this is 3.5. This is the VA. So that means y equal to 3.5 is the VA. Three half is 1.5. So So 1 here, 1.5 right here. Okay. What point is good? What point is good? All right, think about this. What point is good? Okay. Again, I'm gonna say it again if you didn't get it from the other symbol. If I want to choose a good point, I look at the base. The base is 3, right? So if this whole thing equal to 3, then log base 3 of 3 is going to be 1, and that's easy. That's a good point. So how do I know what value of x? Let's make this whole thing equal to 3. How do I know? I'm going to solve this. I let 2x minus 3 equal to 3. 2x minus 3 equal to 3. And then I'm going to solve for x. Plus 3 on both sides. This cancel out. 3 plus 3 is 6. And then divided by 2. 6 divided by 2 is 3. So I plug in 3. Why? When I plug in 3 right here, for sure I'm going to get 3 back. Because that's what we did. Okay, so let's check. Log base 3. 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. Do you see that? So we have log base 3 of 3 minus 1. What is log base 3 of 3?
1,
1. 1 minus 1 is
0,
0. What is the next good one? 6. Yeah, 6. 6 and 2 is 12. 12 minus 3 is 9. Yeah, that's good one. 6. Okay, good. Give 1 point for Sophia. So 2 times 6. 2 times 6 is 12. 12 minus 3 is 9. What is log base 3 of 9? 2. 2 minus 1 is?
1,
What is the next good number?
2.
Do you want to make this one to become? Yes, you become 1. So hey, 1 point for Hayden is 4. And this is 2 because 2 makes it 4. Yeah, 2. Why 2? Because log 3 of 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is 1. Log 3 of 1 is? What is log 3 of base? What is log base 3 of 1? 0 minus 1 is negative 1. How do you know 2? How do you know this 2? I just testing. If you now you understand it. How do I know 2 is a good point?
Looking at the base. 2x minus 3 plus 1.
Yeah. You want to solve 2x minus 3. I want it equal to be 1. I want this whole thing equal to 1. Because log base 3 of 1 is 0. And then I let them equal to 1. I'm going to solve this. So plus 3 on both sides. 2x equal to 4. Divided by 2, x equal to 2. That's why 2 is good. You know how to find this good point now? Yeah, maybe? Okay, so 3, 0, 3, 0. Let me just draw this one. Okay, VA is 3 half, 1 half, 1 half right here. So 3, 0, 3, 0 right here. 6, 1. So 6, 1, we just plug any, this is 6. This is 1. And 2, negative 1. So 2, 2, negative 1 right here. Okay. And connect them. If you have any question, you should ask me. Ask me. What is the domain? X what? The domain you need to x larger than what or
Larger than.
yeah, you can just so inside log is x, yes. Domain is
X is larger than
s larger than 0. Very good. 1 Sophia, 1 for Mark. X larger than 0. What is a VA? the y-axis because this is 0, so VA is y equal to 0, and y equal to 0 is just the y-axis. So this is the VA. What is the good point? It's easy. What is a good point? There's no calculation right here. 1, very good. 1 point is red. 1 because okay, I see this is log base 2. I want this one to be this whole thing to be 1 because this already have x, so x is 1. Log 2 of 1. What is log 2 of 1? 0, right? So it's 3. And then who said 2? I remember someone said 2. Yeah, Sophia, 1 point Sophia 2. 2, because it's a log base 2. What is log base 2 of 2? 1. So 3 minus 1 is 2. What is the next one? What is the next good one? 4, yeah. 1 point for Elizabeth and Sophia as well. So 3 minus log 2 of 4. Because what is log 2 of 4? 2. Someone say, yeah. And 3 minus 2 is 1. Okay. Now to plug it in, 1, 3, 1, 1, 2, 3. 2, 2, 2, 2. And then 4, 1, 3, 4, 4, 1. Okay. The shape gonna look different. Okay. Now it's gonna look like this. Can someone explain why? I give you 2 points. If you can tell me why it look different now. It look different right now.
Because all points are positive, so they're on that point.
The point is positive?
All of them.
Not really. Exactly. Let's just give 3.2 Maria. Remember this one doesn't have any minus. Minus outside everything is flip over. Who remember? If you have a negative outside everything, you flip over x-axis. Otherwise, it's going to flip over y-axis. This one doesn't have any minus, so there's no flipping. That's why it looks like the original one. This one, you have minus outside everything, right? Outside the whole thing. So you flip over the axis. You flip over the axis. That's why it look like this. Does it make sense? That's why it look different. Because there's a minus, there's a subtraction. Very good. And the question for number 6. We're done. We have last one. So bear with me. Okay. I know this is period 6. You are probably tired. Right, ln x minus. Okay, what is the domain? So what is inside the log? X minus e inside the log, right? So x minus e need to be greater than 0. Solve for x. What do you want to do?
X minus e equals 1.
No, solve for x right here.
Oh, plus e.
Right, plus e. X larger than e. So that is the domain.
So what would be the VA?
VA is
1? How's it?
what is that? Y equal to e is the VA. Okay, what is the good point? This is a last example, so it's a little bit tricky. What is a good point? What do you think? Okay, give the good point. I'm gonna give 3 points. Huh? 10? 10 minus e is there give you any good point there?
So e minus
Huh?
2e.
2e. Okay, very good. 3 point for Elizabeth. 2e. Why 2e is good? You plug it in here, you have 2e minus e. Okay. You plug it in x, 2e, you have 2e minus e. What is 2e minus e?
E.
Just e. What is ln e? 1. Right? Natural log e. Oh, natural log of e is 1. What is the next best one? What is the other one? How can you make this one equal to 1? Huh? E? If you plug in E minus E is 0. I want this one to be 1. I want this one to be 1. Just solve this. Just solve that. I want X minus E to be 1. How can I solve this? Plus E. So X equal to 1 minus E. That is the 1. So 1 plus E. Did I say 1 minus E? Yes. Oh, 1 plus E. 1 plus E. 1 plus E. Because when you plug in 1 plus E, let's say what happened? 1 plus E minus E. Okay, 1 plus E is X minus E. What is 1 plus E minus E? 1. What is ln 1? You should answer very fast for this one. 0. When it's time you see 1 inside a log, it will be 0. What is the next good one? I think just choose any. I don't think. Huh? 4E. Okay, let's. How about 3E? 3E. It's smaller. 3E. 3E. Yeah. Thank you. So 3E minus E. What is 3E minus E? 2E. Can you use a calculator to find me what is ln of 2E? Yeah, use calculator. Just use calculator. Natural log of 2E. Any? Yeah. 1.69. Did you all get this? Okay. Thank you. 1.4 data. Okay. Do you know what is E approximate? What is the value of E? 2.7. 2.7. Yes, very good. 1.4 here. Yeah. So 2E is about 5.4, right? Because E is 2.7. So it's 5.4. 1 plus E is 2.7. So 1 plus E is 3.7. 3E is you multiply 2.7 times 3. Huh?
Yeah.
No, not now. So 2.7 times 3 is 8.1. Yeah, about that. So 5.41, 1, 2, 3, 4, 5. 5.41 is about right here. And then 3.70, 3.70. So that's the math, okay? And then 8.1, 1.59. So let me get this one longer a little bit. 8.1 will be this here, and it's the VA is E, and E is 2.7. Okay, so it may be around here. Yeah. You see it? All right, congratulations. You finished the last lesson of the semester. Yay.